Okay, so you also read this book last night, and what were some of the things that you found interesting? Do you have your sheet where you wrote them down? Okay.
I have some questions. I think I wrote down. So the first question is when they fit in the fractions.
Oh, okay. So actually, we have some overlap.
So when they fit in the fractions, how else could they have done that?
Okay.
My second one was, could the imaginary numbers fit?
Oh, interesting.
And what about the complex numbers?
Okay, nice. Okay, so since your brother wants to talk about the fractions, let's talk about the imaginary numbers.
And then my third question is the irrational numbers.
Ah. Oh, great. All right.
Well,
so complex numbers.
I think the imaginary, whatever you call the analogous to the integers, like 1i, 2i, 3i. These are like the imaginary, just the imaginary integers. And these could probably fit because we start off with like 1, 2, 3, 4, 5. We can leave a gap. We can like 1 and then a gap, and then 2 and then a gap, and then 3, and then dot dot dot, and then we can fit I, 2i, and so on.
Ah, okay. What do you think about that procedure for adding in I, 2i, 3i, etc.?
Well, aren't there also like 1i plus 1?
Oh,
two?
Yeah, there absolutely are. He hasn't considered those numbers yet.
Oh.
So just this procedure for fitting in I, 2i, 3i.
So let's see.
So it's full with 1, 2, 3, 4, 5, etc., and then I, 2i, 3i, 4i, etc. show up. And your brother's got a procedure.
Let's see. 1 doesn't move. 2 moves over 1. 3 moves over 2. 4 moves over 3. So basically, what has to happen? So all of the numbers move over 1 less than their number.
Okay.
So I think that could work.
I think it works. Okay, so we can squeeze those in. Okay. Now you said the complex numbers.
Yep. So those are all numbers of the form A plus BI.
And what is your restriction on A and B here?
So they have to be, I think for the case of this book, I think they have to be positive integers.
Okay, so we're going to talk about them being positive integers. Okay, so write down a couple examples. Just
so like
clear.
2 plus 3i, 1 plus 7i.
Okay, nice.
So numbers like this.
All right. So when these numbers show up and the hotel's already full, or actually...
Well, the hotel's full of the positive integers.
Okay, so you have the hotel being full of positive integers. That shouldn't interrupt your story. Okay. Do you think these numbers can fit in?
So I think we can do it by... Well, we can try to arrange them similar to how we arrange them for when the rational numbers showed up, when all the fractions showed up.
Oh, okay.
They kind of arrange them in sort of a triangle. So we can kind of put them in rows, and we can have the number of i's go up as we go up this way.
Okay.
So like, I'm going to redraw this a bit more spread out. So 1, 2, 3. This is this kind of 0i column.
Yeah.
And then we have 1 plus I, 2 plus I, 3 plus I, 4 plus I.
Okay.
And then 1 plus 2i, 3 plus 2i, or, oops, 2 plus 2i, 3 plus 2i, 4 plus 2i, and
Okay.
then...
Yeah, nice. Alright,
So then
we have an infinite number of numbers.
I guess we can do a similar thing to what they did in the book by reading this way. So we put 1 in the first room.
Alright.
And then we put 1 plus I in the second room.
Okay.
And then we put 2 in the third room. So so this is our first group, second group, third group, and then so on and so forth.
Okay.
So then I think we can fit them all in the room this way.
Nice. So you think this is analogous to putting the fractions in?
And then I've just realized I've forgotten the imaginary numbers, but we can just use our old procedure, just fit them in where we fit them before.
Sweet. Okay.
Yeah.
Cool. So nice. So there's some analogous statement between these complex, these are called the Gaussian integers, actually. Complex numbers that just have integer coefficients. And there's some analogy between them and the rationals. Okay, and then the last thing you mentioned was fitting in the irrationals. What do you think about that? Actually, do you want to talk about that in another video? And since we just did, we were going to come back to the fractions. Maybe we could talk about this as the last video.
Okay.
All right, let's do that.